Okay, welcome to the last lecture for Chapter 8, Simple Machines. Just a reminder, guys, we have our test on this chapter coming up very soon. So after this is over, I would start going back and studying the 3 sections from this chapter. All right, so I want you to think about this question just for a few seconds here. So what kind of machine can be found on at least half the students in this room right now? And then think about how machines have changed over time. All right, write your answer down in your journal down below, and then we'll talk about it in class. So we're going to look today at 6 types of simple machines. We're going to talk about the mechanical advantage provided by them, and then talk about compound machines at the very end. All right, so we're starting with the lever, jumping right into it. The lever is probably the most simple and most commonly used simple machine. It has a bar that pivots at a fixed point called fulcrum. All right, so the fulcrum doesn't have to look like this. Don't think they always just look like a triangle, but they do does work as that. Okay, so that fixed point, the fulcrum, is key. So there's three types of levers. The first class lever, the fulcrum sits between the input force and the load. So just to review, guys, remember input force is the force that you do, right? Trying to write you. That you do on the machine. So that would be, in this case, pushing down here on this kind of seesaw-looking thing. And the output force is the force that the machine does on an object, okay? So with the first class lever, the fulcrum is between the input force and the load. Now, when I say load, I mean the weight or the object you're doing the work on right here, okay? So here you can see the fulcrum is in between that, all right? So the closer the fulcrum usually is to that input force, the object has a mechanical advantage greater than 1, all right? When the fulcrum is exactly in the middle between the input and output force, we'd say the mechanical advantage is exactly 1. And when the fulcrum is closer to the input force than the load, we'd say the mechanical advantage is usually less than 1. So that fulcrum, that placement of the fulcrum, is the key difference between all these different levers. Okay. Other examples here: scissors are first-class levers. Your arm is actually a first-class lever. You can see if the hand is the load, the hand is like what the work is being done on. The fulcrum would be at your elbow. All right. So tongs, right? The fulcrum would be right here on the tongs, and obviously the seesaw here, right? We've got the load, fulcrum, and your effort or your input force. We can call that too. Input force right here. Second class levers, and with this one, the load is between the fulcrum and the input force. So here you can see how the fulcrum has moved here. Okay, in this second class lever, the output force or the load is between input force and the fulcrum. So the second class lever usually always results in mechanical advantage greater than 1. So this is a great one for, obviously you can see the wheelbarrow as an example. Opening up a can of soda is the same. Also takes advantage of that mechanical advantage. Right. More examples of second class levers. You can see those nutcrackers again. Here you can see how the fulcrum is positioned here, the second class lever. The car door swinging is another example of a second class lever. Okay. The wheelbarrow, when you lift the handles of the wheelbarrow, it rotates around its fulcrum. All right, so the input distance is greater than the output distance. So the increased input distance means it takes less force for you to lift the load. So the second class lever always results in MA or mechanical advantage greater than 1. All right, so that's why you can put such a heavy weight here, right? Because it's increased that distance. Third class levers, the input force of a third class lever is between the fulcrum and the load. So here's the input force, is the work you're doing on the object. It's between fulcrum and the load this time, right? All right. Okay, so This results in mechanical advantage less than 1, all right, because the force is decreased. So the third class levers increase the distance to which the force is exerted. So, when you're lifting weights, you want to be you don't want it to be too easy, right? So you want the mechanical advantage to be a little bit lower. When you're swinging that heavy hammer, you've increased the distance you're moving the output force, and your input force is always a little bit lower here, okay? So just remember the third class levers give you a mechanical advantage less than 1. For examples, baseball bat, you can see a guy looks like raking leaves, and the fishing pole. All right, so with the fishing pole, again, you can see the input force is here between the fulcrum and the output force. The fulcrum is here, okay, and then the load of the output force is here, okay? A pulley is a simple machine that consists of a wheel over which a rope, chain, or a wire passes. All right, so there's actually a few different kinds of pulleys. We've seen pulleys before, remember? Pulleys change the direction of a force, right? So the input force might be down like this, and the output force would be going up like that, okay? A fixed pulley is attached to something that doesn't move, right? So your flag has a fixed pulley on it. You're pulling out the flagpole. A movable pulley, unlike a fixed pulley, are attached to an object that's moved. Okay, and finally the last one, when a fixed pulley and a movable pulley are used together, the pulley is called a block and tackle. So to review, we've got fixed pulley, movable pulley, and a block and tackle are the 3 types of pulleys. Here are some illustrations. All right, so in this one, the pulley just spins, right? Just spins right on its axle right there. And the forces are the same, okay? So with a movable pulley, it moves up with the load as the load is lifted. So the mechanical advantage is this pulley is 2. So this one gives you a greater output force, all right? Because as you pull here, this comes up with the pulley. So imagine the rope here kind of being coiled in the pulley as it gets pulled up, okay? And that gives you a greater mechanical advantage. Now, when you add another pulley, it kind of makes sense, right? So the mechanical advantage here would be even greater. So these pulleys are spreading out. Remember, they spread out the force. Imagine the force is just wrapped all along these wheels here. So we're just continuing to spread it out and do less work yourself. So you can lift something quite heavy by using the block and tackle pulley. All right, and multiplies the input force by 4 this time. All right, a wheel and axle, super common. A wheel and axle is a simple machine that consists of 2 circular objects of different sizes. So you've got to have, in this case, the axle is one circular object, and the wheel is up here is the handle, okay? So you can apply a small force to the wheel, and it rotates around the axle. So as the wheel turns, so does the axle, but because the axle is smaller than the wheel, it rotates a smaller distance, which makes the output force larger, right? So if you make the distance a little smaller, you increase the amount of force that's being done. All right, so the mechanical advantage of a wheel and axle can be found by dividing their radius, the distance from the center to the edge of the wheel, by the radius of the axle. So you take the radius of your 2 circular objects, you can see those radii are both here, right? And you divide them. So take the input force, and divide. So in this case, the mechanical advantage is 5. So it's just like any other mechanical advantage question. You take output force and divide by input force, but you just need to think about these 2 as each, right? So this would be the output. Oops. And this is the input force, okay? And if you think about it, you are exerting work on the input force, okay? All right, so an inclined plane, another AKA kind of like a ramp, really, is what that is. is a simple machine that is a straight slanted surface. So the mechanical advantage of this can be calculated by dividing the length of the inclined plane by the height for which the load is lifted. All right, so it's pretty easy. You're taking the length and dividing it by the height. Right, so if a heavy box is pushed along a ramp that's 4.8 meters long and 1.8 meters high, you can find the mechanical advantage of that by just dividing to get 4. All right, so this lets us see how helpful a ramp is as you are trying to move an object. All right, so go ahead and try those 3 right there, and I'll check back with you in a minute. For number 1, you should have gotten 6. For number 2, you also should have gotten 6. And for number 3, you should have gotten 0.25. Okay, so an inclined plane has kind of 2 simple machines within it, right? So a wedge is a pair of inclined planes that move. So think about a wedge as like, so one inclined plane looks like that, right? Like a ramp. Oh, and there is another inclined plane on the other side, right? So each of these are inclined planes, but they're together to make up the wedge, all right? So wedges are great because that's sort of how we can pry things, right? When you think about a crowbar, screwdriver, a lot of things, those are all wedges, okay? Mechanical advantages of wedges can be found by dividing the length of the wedge by its greatest thickness. So you can see the length here is 8 centimeters. Its greatest thickness is 2. So you can figure out the mechanical advantage as 4. So it's pretty much the same thing as an inclined plane because you're looking at the length of the inclined plane and its height, which obviously would be, the length of its thickest point. Okay, so we can find a knife is also a wedge. You can see there in the picture of the. Let me write that down. I have a new stylus, which is terrible. The knife, we could say a pry bar, crowbar. Those are all wedges. Okay. A screw is an inclined plane that's wrapped in a spiral around a cylinder. Sounds kind of complicated, but if you take a piece of paper, you can kind of see it's modeled there with the pencil. You can just wrap that around a cylinder, like a pencil, or like some kind of tube. It kind of forms what looks like a screw, right? So if you look closely at a screw too, and I'll show you on the next page, it's essentially just a ramp that goes around the screw. So the mechanical advantage of screws, the longer the spiral in a screw is, and the closer together the threads, which are sort of like the the spiky things on the side of the screw is the only thing I can think of. The closer those are together, the greater the mechanical advantage is. So it's almost like the tighter the screw is, right? So I thought I had a picture of a screw. Well, I don't. But if you don't understand the mechanical advantage, the description of a screw as a wedge, as a type of inclined plane, go in the textbook. They have a good picture, an explanation there. So compound machines are the last thing we're going to talk about. Really simple. You guys know what compound means. Like compounds, when we talked about chemistry, were 2 elements kind of fused together, bonded together. If you take a compound sentence, right? It's 2 ideas kind of mushed together. Same thing. A compound machine are machines that are made of 2 or more simple machines. All right, so just pause and think to yourself, do you think a machine gets more efficient or less efficient the more simple machines it has? Well, the answer is that the efficiency of most compound machines is low, because that means if there's more machines, there's more moving parts. Therefore, there's more friction to overcome, right? So if we go from left to right here, these machines are more and more complex. Therefore, they're less and less efficient. So there's the pencil sharpener to the mixer to the crane, whatever that is there. Think about it, there's just more simple machines within these, right? They're just increasingly complex. And so compound machines are great. Most of the things that you guys came up with in your homework the other night, where you're looking around the room and you're thinking about machines in your home, those are our compound machines. So if you strip those machines away, you could look and say, hey, someone did like a drill. My drill has, gears in it, right? Which take advantage of, they're really just levers, right? That kind of also have a wheel and axle in them, that also have an inclined plane around the screw part of the drill, right? So they're all just combinations of lots and lots of simple machines. All right, so what I want you to do now is to try and fill out that last kind of picture you guys have at the bottom of your notes. Try and figure out what simple machine is what, and then I will, when you're ready, I will magically reveal the answer. So you should be working on that now. La 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 la. Keep working on it. Pause the video, because you're honest, good little Catholic boys. You will listen to me and actually do it. Okay, so now you have completed it. Here are the answers. You can see the first one is the lever, right? Here is your fulcrum, oh boy, RM. Okay, there's your fulcrum. You can see the input force here. You can see the output force there. You can see the wheel and axle here, right? You can see this thing turning over here, spreading out the force. That's the axle. You can see the pulley spreading the force out over there, changing directions of it. The inclined plane is the ramp. You can see the wedge here. Actually, hey, they're all in order, aren't they? And you can see the screw, which is essentially just like an old school kind of, what do you call those things? The jacks you jack your cars up with, okay? All right, cool. Well, study these notes. Know them really well. We're going to have a short quiz when you come back to class. That would be either Friday or Monday, depending on what class you guys have. And don't forget, don't wait to start studying. Start studying Chapter 8 now. Some review materials are coming out to you soon, but don't wait for them. Start studying now. Have a good night.